Probability and statistics, the counting principle. If you're doing permutations and combinations, it's better to go straight to my permutations and combinations part 1, because this is included in that video as well as an introduction. So when dealing with the occurrence of more than one event, it's important to be able to quickly determine how many possible outcomes exist, particularly in probability. So here's an example. There's an ice cream sundae with 5 flavors, and there are 4 possible toppings for that sundae. How many different sundaes can be made with 1 flavor of ice cream and 1 topping? So let's look at the options. Ice cream flavors above, toppings below. So vanilla has 4, each of these has 4, so altogether we have 20. Now, by the counting principle, it's far easier than having to list these and then add them together, is to say, if there are 5 options for the one and 4 for the other, then we simply multiply them together. That's the counting principle. So it works for 2 or more activities. Let's look at another example. A coin is tossed 5 times. How many arrangements of heads and tails are possible? Well, there are 5 different trials, 5 different occasions. So we look at the option for each. Well, in the first case, we have 2 options, head or tail, and then second head or tail, head or tail, head or tail, head or tail. Altogether, there are 32 arrangements of heads and tails for the 5 coins, and we've used counting principle to do it by multiplying. It's a simple principle. Just multiply the number of ways each activity can occur. So let's have a look. Here's a number of books. We're arranging 4 books on a shelf. And the question is, in how many ways can I arrange those books on the shelf? Well, the first place I have to choose 1 book, from which I have 4 options. Now I've used 1 book, so when I get to the next place, I only have 3 choices. Then 2, and finally no choice, the 1. So it's 4 times 3 times 2 times 1 is our counting principle result, giving us 24. Now there's an abbreviation for that 4 times 3 times 2 times 1. For exclamation mark, it's 4 factorial. And you have it on your calculator as well. Just look for the exclamation x factorial or n factorial on your calculator. N factorial is n times 1 less than n times 2 less than n times 3 less than n, all the way down to times 2 times 1. So a bit of practice with factorials. Try these yourself. Use your calculator if you'd like to. Just be careful of this 3 factorial times 3 factorial and this 9 factorial. Right, 5 factorial, 120. 5 times 4 times 3 times 2 times 1. That is 6 times 6, 36. What do we notice? This is considerably larger than that one. Some might think that this becomes 9 factorial, 3 factorial times 3 factorial, but they are not equal to one another. So the principle is you cannot multiply factorials together. This one here, 7 factorial, is 7 times 6 times 5 factorial, which is cancelled. 7 times 6 times 54321, which is that one, 54321. So I'm left with the 7 times 6, 42. n minus 1, and then n minus 2 downwards, and there's the n minus 2 downwards, cancelling with it, so I'm left just with the n minus 1. In this case, I look at the 12 factorial, 9 factorial. That means 12, 11, 10 with the rest cancelled by this 9 factorial. And we have the 3 factorial. So 12, 11, 10 over 3, 2, 1. So that arrangement is called a permutation. We permute the books. A permutation is arrangement of the elements of or from a set of S numbers. Of or from. So if you're using all of them, it's of, but you could be choosing from the set. Let's have a look at the set S, A, B, C. CBA is a permutation, as is BCA, a different permutation. Now we're going to go on now to an example where we have more than 3, where we're only choosing 3, or the equivalent anyway. Here we go. Now we have 10 books and we're only arranging 4 on the shelf. So first option, we don't have 4 possibilities, we have 10 possibilities. Now we've used one of the books, so therefore there are only 9 left now. Then there are 8 for the next one. And 7. So it's 10, 9, 8, 7. So, look how this has worked. It's 10 factorial with 6 down cancelled. So where does the 6 come from? From 10 minus 4. So 10, 9, 8, 7, and then we've cancelled 6 downwards. So this is called an R permutation, being a permutation of R objects from N objects. We can use a number of notations. There's even more. There's a superscript N and a subscript R as well. But we're going to use this first one. And that means N factorial over N minus R factorial. So the N is the 10 and the N minus R is the 6. So our book arrangement is 10p4. So let's look at another example. How many different numbers can be formed with the digits 1 through to 5? Repetitions allowed, and the number has 5 digits. So 5 to choose from. We can repeat, so all 5 digits can be used in each of the 5 places. So let's put it in table format. Positions 1 to 5, and there's 5 choices for each of those positions. By the counting principle, we multiply those two together to find the number of different arrangements, in other words, number of different numbers that can be formed. We get 3, 1, 2, 5. In B, 3 or 4 digits. Now, there's a problem with that. A 3-digit can't be 4-digit, and a 4-digit can't be 3-digit. So these are mutually exclusive. You have the one or the other. So we need to calculate their numbers separately. 3-digit. Let's set up the table. 3 positions, 5, 5, 5 options. With a 4-digit, 5, 5, 5, 5 options. Now, being mutually exclusive, one or the other, we can add them all together. So therefore 750 objects in total. 750 numbers. 3 or 4 digit numbers. Now let's do the same question, but this time the repetitions are not allowed. So we'll go through the same process, but now because we can't repeat digits, we'll be using the permutation principles. In the table, instead of 5s now, we have 5, 4, 3, 2, 1. Because we have 5 options for the first, but we're not allowed to repeat, so therefore there are only 4 digits left for the next, and so on. That, of course, is 5 factorial. 3 or 4 digits, we're going to have to do it mutually exclusive again. So 3 digit, 3 places, 5, 4, 3. And that is 5p2, 5p3. Notice 5p3, 5 factorial over 5 minus 3 factorial. 4 digit, 5, 4, 3, 2. And that's 5p4. And at the end, we add them together. Right, let's have a look at another one. A car registration number made up of 3 letters, excluding vowels, and a number of 3 digits. Now, you might wonder why excluding vowels. As soon as you have vowels inside there, it can form words, and there could be quite a few rude words, and that's why they exclude them. So nobody's landed with a registration number which could embarrass them. So we're going to use the counting principle. We have 3 places with letters, and there are 21 options, because if we take away the vowels, 21 letters left. And there are 10 options there, 0 through to 9. So, the options. For first place, 21 options. No letters may be repeated, so 20 and then 19. Now, it doesn't say anything about not repeating the numbers, the digits, so therefore we can have 10, 10, 10. By the counting principle, we multiply them together and we obtain that number, which is actually 21p3, an arrangement of 3 letters from 21, arrangement, times 10 cubed. If the letters may be repeated, then we're no longer going to say 21, 20, 19, because that can have 21, so can that, so can that. And the same as the digits, and therefore 21 cubed times 10 cubed. Another car registration one with a couple of other complications. Now 3 letters and 2 digits, but we cannot use O and Q, and we cannot use 0. So there are 24 options for the letters, and there are 9 options for the digits. No other restrictions. So, 24 to choose from for the 3 positions, and 9 choices for the other. So, number of registrations, letter, 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 number, number. 24 cubed, 9 squared, giving us that number. B. Only the first place has a restriction. First letter must be a consonant. So there are 21 consonants in the alphabet, and we're taking Q out. So therefore 20. So you see we have 20 options for the first place, but then 24 for the other 2 letters, and still 9 for the remaining digits. Vowels and consonants must alternate. Now this is once again going to be a mutually exclusive, because either it starts with vowels or it starts with consonants. If there was the same number of vowels and consonants, then we'd be able to work it as a single. But not in this case. There are a different number of vowels and consonants, so we have to do two separate calculations. Starting with a consonant. Right. There are 20 consonants. So therefore we'll have 20, 20 for the consonants, 4 for the vowel, and 9, 9 for the digits. Starting with a vowel, now we can't use the O, so therefore we only have 4 options for the vowel, and 20 for the consonants, because there are 21 less Q, and 9, 9 for the digits. Adding together, because they are mutually exclusive, there's the total number. Right, in this case, 10 volumes of an encyclopedia placed in any order on a bookshelf. What's the probability that volume 1 is first and volume 10 is last? Well, a reminder, probability, number of favorable outcomes over total number of outcomes. So we need to find the number of outcomes with volume 1 first and volume 10 last, and then the total where there are no restrictions. So for favorable outcome, we need volume 1 there, volume 10 there, and we are arranging 8 volumes, which is 8 factorial. Total outcomes, there are 10 to arrange, arranging 10 items, that's 10 factorial. Put favorable over total, and there we are. Three of the letters from the word space are arranged in a row. Now this is no different from arranging 3 of 5 books. Five for the first, 4 for the second, and 3 for the third. And there we are. It's 5p3. Combination, a permutation, an arrangement of 3 from 5. Now, in how many ways can the letters of the word sleepiest be arranged? Oh, easy, 9, hey? Same as the previous. We don't have to look at it, but hang on. The E's and S's are repeated, and that causes a complication. Here are 6 of the 9 factorial. This is just one group of 6. Now, I don't know if you can see why I've chosen it, but you'll see everyone has an S, L, E, E, P, I, E, S, T. Everyone has the same. But what I have done is I've arranged the E's in different orders in every case. So there are 6 different arrangements, and 9 factorial will include those as 6 different arrangements. But are they in fact different? They're exactly the same. Because you see, when we're arranging the letters of the word sleepiest, we don't see E1, E2, we see EE. So how are we to know? So every set of 6 words in which only the E's appear to be arranged is really only one word. And the same happens for the S's. Every set of 2 words where S's but nothing else appears to be arranged, it's only one word. So we're going to have to divide by 6, because instead of 6, that's 1. And so the whole arrangement, all the arrangements come in sets of 6, where every set of 6 is actually 1. So we must divide by 6, which is 3 factorial, the number of arrangements of the 3 E's. And we've got to divide by 2 factorial for the number of arrangements of the S's. which means 9 factorial, yes, but we must divide by 3 factorial for the S's, 2 factorial for the E's. Mathematics, have a look there now. Write the word mathematics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So we could say 11 factorial, but there are 2 M's, 2 A's, 2 T's. So therefore we must divide those out. So 11 factorial, and we must divide out by 2 factorial, 2 factorial, 2 factorial for the M's, the A's, and the T's, giving our final arrangement. But what's the probability of obtaining 7 heads and 3 tails when spinning a coin 3 times? Now this is 7 heads, then 3 tails. So there we are. It depends on the number of arrangements. Well, no. There we are. 7 heads and 3 tails. Now there's a number. It doesn't depend on the arrangement here really, because we could have the heads in any order, the tails in any order. It's no different from the last 2 examples. It's just a strange word with repeats. It's a word with 10 letters, but the H's repeat 7 times and the T's repeat 3 times. So in fact, we're going to work by the same thing. Arrangements of 10 items with 7 repeats and 3 repeats. There we are. 120. And there's our answer.